Hello, everyone, and welcome to our customer training webinar. We are talking today about what's new with FAST. So we're going to cover 5.4, some of the major features to know about for you all FAST admins, and then as well, we're going to talk about what's coming in 5.5. So with that, I'm going to invite our presenters to the stage. We've got Phil Wagstrom from the Office of CTO, and we've got Jason Massey as Technical Marketing Manager, and we are going to roll right in. You do have a chat feature that you can use in Q&A. So if you have questions, we would love for you to put those in the chat. We have a team standing by that will do some answering there or throw it to the presenters as well if it takes a longer answer. This webinar is recorded. So after the webinar, you'll get an email with the link to where we post those, but it's basically on our FAST YouTube channel under customer training webinars. So with that, Phil and Jason, why don't you join me on the stage?
All right.
Morning, Kristen. Hi, Jason.
Howdy.
All right. I'll let you guys introduce yourself and take it away.
So I'm Phil, the Office of CTO here at Vast Data. I'm joined on stage here with Jason Massey. Go ahead, Jason, introduce yourself.
Jason Massey. I'm the technical marketing engineer for Vast. And today we're going to talk about all things 5.4 and maybe some future stuff. So let me get started here. All right. So in 5.4, there was, this is a pretty big release. There's quite a bit in this release. This is just kind of a quick overview, kind of showing all of the different features and functionalities that were added in 5.4. One of the things that was a big change in 5.4 is as of 5.4, we're now calling it the Vast AI OS. And you'll see some of that and why we're calling that once we get into the data engine aspect. So let's jump into some of the features here. So one of the things that's been added is security STS for S3, so security token service for S3. So what this allows you to do is connect to a bucket using temporary tokens. So the way this works is with using the least privilege, so basically only connecting using that account and only for a certain set of time. So by doing that, we can also set up automatic expiration. This again increases the security because you're only going to be allowed to use that temporary token for a short amount of time. It can be set up to be between 15 minutes or up to 36 hours. So that allows for, again, more granular control. Again, that also automatically expires. One of the other big benefits of the STS for S3 is that you also have an audit trail. So all of the functions that use this STS we're allowed, it stores and audits, allows you to audit all of the functionality with this functionality when you enable it. There's a couple of different options for the IDP. So this, again, allows customers a little bit more options in what they want to use when they're doing the STS for S3. The next feature here is server side. So the SSEC, so we're adding this functionality that allows the customer to manage and control the keys on-prem. So now the customer itself will manage all of the security, encryption, and keeps everything on-prem for those that maybe have very tight policies, allows for enhanced security. A lot of times this is used where customers want to manage the keys locally and not have them go off-prem. So the keys will only hold that functionality during the operation, and then once that's done, it will then release that key, and it will need to be supplied again if it needs to do another function. Another function that was added is SMB encryption. So this, again, adding more security to the platform, provides data protection and integrity across the wire, can be configured at a view or a tenant level, ensures that data is not tampered in transit. And now one thing to be aware of is that there can be up to a 15% impact on performance because we are processing and encrypting that data as it goes across the wire. So something to be aware of if that's something that you're going to use. Another function that we added, MIT Kerberos. So what this allows customers to do is another authentication method for those customers that are not using Active Directory. Currently, this is only supported for NFS v4. We'll continue to work on that for other protocols. Support for Kerberos B5, Kerberos 5, 5i, and 5p. And then also the way that this can work is with Kerberos and LDAP or Kerberos and VAST local servers, or excuse me, local accounts. So again, the idea behind the MIT Kerberos is giving customers additional authentication methods, especially for those that are not using Active Directory. Another function that was added, and this is a performance functionality, is NFS for delegations. So what this will allow customers to do is for the remote clients, we can set up delegations, which will then now you can enable basically the easiest way to think about this is kind of a remote cache functionality. So instead of the client having to continuously check in with the server to do reads and writes, we can do a delegation. You can do multiple delegations for reads, but only one delegation for writes. This is really good for lots of small files, and you can actually gain up to about 2x performance increase. So again, this is a performance functionality for NFS v4. Just you have to be aware of the lock functionality or the caching functionality with the reads and the writes, where writes are only permitted by one client at a time. Another functionality is we've added numbered BGP. So this functionality is an enhancement to the existing BGP that doesn't use numbered BGP, so uses IPv6. This allows customers to do a different type of deployment if needed. So again, just adding additional functionality to the platform and additional features within the networking stack. So now jumping into the vast data space. One of the big things that we enhanced in 5.4 is the ability to do global namespace on the same path as an asynchronous replication functionality. So previously, some of that functionality had to be separated by either different cluster destinations or the fact that you could not do the same path on the same cluster destination. So now we support that functionality where both global namespace and replication can be on the same path to the same destination servers. This allows for ongoing DR and works for one-to-many or many-to-one. We've removed a lot of the limitations that used to be on the VAST catalog and replication. So now there's no need to disable the catalog when we're doing replication or doing any changes. We can allow more than one replication. And also the way this works is that we'll go in and remove the rows elements, do the replication, and then do a sync and then reinsert the rows. So basically the premise on this one is that there's no more limitations on the catalog and replication. Jumping into the database aspect of VAST, what we've added here is a vector store and search functionality. So a lot of times when customers are using AI or they're wanting to do some vector functionality, this required external functionality. We now have added that to where you can run a vector store directly on the VAST platform. So this allows for the vector functionality, especially for AI functionality, where we need to use that vector capabilities. We have a couple of different options in the search functionality. We've got Euclidean, cosine, negative inner product distance. And there's additional features that we'll talk about how we're going to enhance the vector going forward as well. Some other database functionality, we've added data row and column security. So this allows you to share out database content, but limit what is shared. So if you had a certain row or column that you wanted to block read or access to somebody, you could grant them access to certain columns or certain rows. Another big enhancement is adding the support for running Trino or Spark directly on CNodes. So this is a big enhancement because what this does is simplify the deployment of Trino and Spark by allowing you to deploy them directly on the VAST platform. So by doing this, you no longer need to have external servers or functionality to run this functionality with the Trino or Spark. Now it can be run directly on the CNodes. And with the addition of being able to modify or add additional compute alone with the disaggregated, our days infrastructure, this allows you to increase the compute as needed for this type of functionality. So now we'll get into a little bit of the data engine or insight engine. This is where the AI OS functionality comes into play within 5.4. So when we look at this, insight engine is more of a concept or a construct, where data engine is actually the physical functionality within the VAST platform. So if we look at this image here, it kind of gives you the idea of how this functionality works, where we've got our protocols and our sync engine functionality, their actual physical functionality and products, the data engine, which wraps all of that piece into one area. And then the insight engine is where we get into the servers and the serverless functionality for triggers and functions. And we're going to go into that a little bit more. I'll talk about that. And then Phil is actually going to do a demo in a little bit after that. So when we talk about the triggers currently for Kafka topics, what this allows you to do is go in and set up triggers for certain events. So if you need to go in and you want something to happen, whether it's you can set it for schedules, you can set it for an occurrence of something that happens, a file changes, a file gets created, deleted, whatever. Any of those functionalities can be triggers. And those triggers can then result in creating functions. So you can come in and create functions that trigger will initiate. Stuff like doing code, taking action, creating a log, setting a permission. There's all kinds of things that you can do. And basically, your imagination is the limitation on this, on what you want to do with these functions. So to kind of give you an idea of how this could possibly work, and how this is kind of this first slide shows the basic understanding of how the serverless functionality and the triggers and functions work. So we have an input that happens. So something comes into the file system. Then we have the event broker. The event broker will be monitoring the file system or a bucket or a file or whatever it might be. And from that, we can set up functions that happen. Those functions, again, like I said, could be different actions, logging, events, notifications, whatever they might be. And this can be used to trigger S3 events initially. And we're working on additional protocols, NFS, stuff like that. So this is just kind of the rough architecture of how these triggers and functions work. If we go into a little more detail, going into kind of the AI functionality, we can look at a RAG high-level pipeline example. So we've got a data source, and that's going to put out some information into the file system. That file system, then the event broker will be watching, and this is where you would set up the triggers. When those triggers happen, they can then go out, go in, maybe reach out to some NVIDIA NIMs, do some GPU functionality. That then can produce that information back to the vector database, which is again why we added the vector database. This is part of the whole AIOS. Once it's in the vector database, we then can do functionalities where there's an input request or asking a question or whatever it might be that requires some type of AI functionality, goes out, queries the vector database, goes back up, does a RAG functionality, returns that information, and then returns that answer back into the user's prompt. So this is a little bit more of an overview of how the RAG functionality works. Again, this is working all based on the direct GPU functionality and the triggers and functions that we've added in 5.4. Now, here's a couple of FAQs. Embedding models with NVIDIA NIMs. We've got the Insight Engine, which is agnostic, designed to integrate with embedded model services. The NIM lifecycle is handled. How is that handled? Customers are responsible for managing the lifecycle, their NVIDIA inference functionality. So that isn't on the VAST platform yet, but currently that would be external to the VAST platform. Will VAST provide native model lifecycle management in the future? Yes, this is actually a future functionality that we're going to add in later releases. How is the Insight Engine different than the VAST data engine? So remember what I said earlier when I showed that diagram. The Insight Engine is a concept or construct of all of the functionality that it requires that runs on top of the data engine. And so that's how, when you think about how that's going to work, that's the idea between the difference between the Insight Engine and the data engine. So before I jump into our key takeaways, I'm actually going to hand it over to who was next? Was Phil going to dive in, or is it going to be, are we going to do some roadmap stuff?
I believe we're going to hand this off to Tomer as he's got a flight there. And Kristen, you're muted.
There we go. Sorry about that. Yes, we are going to hand it over to Tomer now. He's going to do a preview of what's coming in 5.5 in our next release. We like to give both what happened in the current release and also what's coming for you all. After that, then Phil is going to do a demonstration of one more thing, and then we will wrap it up and answer some additional questions. So with that, Tomer, I'm going to hand it off to you.
Awesome. Can you see my screen?
Yes, we can see your screen.
Yeah.
Okay, I was concerned for a second. Okay, great. Thank you very much. So as Jason and Christine mentioned, we're going to talk about some features. So it's nice to look at the existing features, what's available now in 5.4, and then some of the evolution. And just like Jason selected a few of the 5.4 features to share with you, right? In every release, we have dozens of features. We selected a few. I selected even a fewer number of features just to give you a taste. And of course, we want to cover other things in this session. So here we're talking about roadmap. Usually we don't share roadmap in public forums, but this webinar, we've done that last time with a handful of features. And we're going to do it now because we received some good feedback there. So I selected a feature from every category. So starting with our data store. So for data store in 5.5, we're going to have what we call the dbox decommission. So some of you may know that we can already migrate data from dboxes to dboxes. So, when you build a vast cluster, the cluster can grow forever, right? You can add CNodes, you can add dboxes as data grows or performance needs grow. But we didn't have a way to shrink clusters. So let's say you misplanned or calculated and you would like to move a dbox from a cluster on site A to a cluster on site B. And now with with this upcoming feature, we'll be able to do that, right? So decommission older hardware, for example. We already able to do this with replacement, with what we call migration today. So if you would like to keep the same cluster size, you can remove older hardware and put new hardware that's available today. But decommissioning old hardware without adding new hardware is what's available in 5.5. So really just shrinking clusters if they're underutilized, all sorts of scenarios, if you loan some equipment. And the nice thing about this is that the same functionality and the same capability will allow us to also offer that for cloud instances. So VOC is vast on cloud. And when we build a cluster in the cloud, we'll also be able to scale it down as you'd expect from a cloud service. So this is the first feature I wanted to cover. It's coming in 5.5. The second one is around data space. So data space, as most of you probably know, is in our umbrella name for a set of capabilities that allow us to share data between clusters. So replication falls under data space. There's global snapshots, sync replication, async replication, and of course, global namespace. Global namespace has been with us for a while, and write leases is a major enhancement that will allow remote sites to write data locally. So we have a little bit of an animation here that I'd like to share. So if we're looking at this global namespace, so let's say that data is shared between New York and London. When a client in New York writes data to its local cluster, this data is been written. It will be written locally, and the client will receive an acknowledgement immediately because they're writing to this local cluster. In our example, London is a satellite cluster, and it serves as an extension of the file system. And we won't get into a lot of the details needed for understanding how global namespace works behind the scenes. But one of the key features and one of the key traits is that we have strict consistency of the data across the entire namespace. So if someone from London writes into this /data path, the data will traverse all the way to New York because that's the source, right? That's the source of truth for the entire namespace. And so writes are much slower if done from a satellite, in this case London, compared to New York. And so with 5.5, as you can see on the screen, it's going to be a preview feature for 5.5, and 5.6 will make it a GA. Will improve this functionality, right? This is already a unique capability, but what we'll be able to do is detect that writes are now coming from London, and will assign what we call a write lease to this remote site, such that it can receive and acknowledge those rights locally. So we're handing over the ownership for part of the namespace to this other cluster, right? And there's more details, of course, of how this works behind the scenes and how we can consolidate data afterwards and things like that. But what we're doing here, we're optimizing for writes, in addition to all the read optimizations that are already available with the global namespace today. So moving forward to this next feature, and this is the slide that Jason showed just a couple of minutes ago. So you can see, I'll just build this here. Right? This is the entire flow there, right? And that's what we have in 5.4. In 5.5, we're going to take this whole pipeline and RAG and serverless functions and all those use cases. We're going to take them a few steps forward. And so in 5.5, I chose to show or to share those three elements that are essentially all related. So the first one is what we call vast managed containers. So we'll be able to run containers that power those serverless functions inside the vast cluster. Right? So we'll have a Kubernetes cluster with vast managed containers running those serverless functions that are required for those operations. We're going to use this infrastructure and build reference RAG applications. So I'm not going to share which RAG application I'm going to build now, but because the public nature of this webinar. But as Jason mentioned, right, the whole engine architecture allows us to build any type of pipeline with those reference architecture, with those reference applications. We're actually delivering content on this framework. And then the last part is NIMs as a service. So I'm going to show you this picture now, and the subtle change here is that the top part is also has a vast logo because we manage those NIMs, right? So if I'll summarize what I shared, right? So now this whole flow will benefit from Kubernetes containers inside the cluster. And I'm just going to build this here. So NIMs, right? So the NIMs that normally someone will have to stand up on some kind of a GPU-powered compute, will have to manage that. In version 5.5, we'll do all that, right? So we'll be able to run those inference services. And we're going to build those RAG applications. So all those flows and all the steps that Jason walked through, right? These will all be served as or offered as an application rather than a framework that you build your own application. You could still do that, but we'll be able to offer that as a reference application. So with that, this is what I wanted to cover. So really building on what Jason covered, starting from 5.4. These are some of the additions in 5.5, and now let's look at how things actually work in 5.4 with Phil. So.
All right. Thank you so much, Tomer. That was great information. And Phil, you go ahead and take it away with our demo.
Sure. Thanks, Tomer. Thanks, Kristen. So yeah, so let's talk a little bit about. I'm gonna give a quick brief overview of Data Engine, how it looks on Vast, how you do some of the initial setup, and I'm just gonna run a very basic pipeline here. So let me share out my screen, and we'll take a look here. So I'll go through share out my entire screen. Hopefully, it's not too noisy. But what we have here is, let's validate that comes up, and good. Okay, so what I have here is I have a vast 5.4 cluster. I'll make this a little bit larger so we can see what's going on. And this is your typical standard, tenant administration window. So I've got multiple tenants on this cluster. What I'm working on here is I'm working on a database engine tenant. This is where we have configured under. This tenant itself, aside from the name, is no different than any other tenant, but we have some additional features that are turned on here. So if I go through and look at this tenant, we have various different configurations here in terms of the providers that we're using for authentication and so on and so forth, as long as the URL for tenant administration. But the one key portion of this here is that we do have a concept of a tenant admin user that allows users to go through and log into the tenant here, and we also have a data engine portion of this as well. So with data engine, we have data engine enabled for this, and along with the data engine configuration for any one of these things, we have to go through. We have to configure some certain things. So again, as was talked a bit with Jason and with Tomer, for the entire pipeline today, not everything lives directly within VAST. The Kubernetes clusters or the Kubernetes systems that are being used are currently sit outside of the VAST cluster. Coming with 5.5, we're looking at bringing that into the cluster so it's completely managed. But right now, we will interface with those existing external clusters. So we go through here, and when we enable Data Engine, we define which Kubernetes clusters or which clusters are available for the VAST data engine to go through and interface with. So we have these configured here for this. Additionally, with that as well, we need to provide it with some Docker repositories or some container registries to be able to get information for assembling these pipelines, so it knows what to trigger, where some of these operations are, what needs to be staged. So once that's set up, it's very easy to go through and manage it. At that point, a user that wants to make use of this functionality doesn't have to know anything else about VAST. The storage administrator would maybe set up some S3 buckets, or they would set up some available space for the end user to use. But at that point, after that's done, the end user that wants to make use of these pipelines doesn't have to really know anything about VAST. When they want to come through and they want to access and want to set up some of these pipelines, they would go through and log into the VAST interface here. It's going to be the same interface that we'd use for a tenant admin, but they're going to be presented with slightly different information, slightly different screens. So when I log in here as an end user, I'm going to use a username of pwagsSE. And this is just a regular user that is out there. They're going to log in and they're going to be presented with this data engine screen. This is much different than the VMS screens for storage administration. This is strictly for managing data engine and managing those pipelines. So in the case here, we would have certain S3 keys that need to be set up in order to be able to go through and access things. We generate those, would be prompted for those when we initially log in. For that, but once you do that, we can go through and configure our pipelines for this. So with the pipelines here, we have to start out with some elements that we need to define. So we have various different triggers that we can go through and define. And these triggers can either be of a couple different types here. They can either be a trigger type of something, an element showing up, and again, this is going to be let's say we do a put on a directory or a put on an S3 bucket. We could trigger something based on an element showing up, or we could go through and have this triggered based on a schedule. So let's say we want to occasionally go through and scan a directory and look for certain things rather than being triggered off of the input for things. So I've got two different triggers defined. I'll kind of just give you a quick overview of these here. So this first one here is just a very basic, every hour, once a minute, I'm going to go through and do something. It's scheduled as kind of like a cron job here. We can go through, we can schedule this as we want. Pretty basic, nothing too exciting there. This other one here is one where I am going through, and this is going to be triggered off of an object being uploaded to a bucket. So let's kind of break down what this looks like. So again, this is going to be an element trigger type. It says, okay, for anything that gets put into this bucket, we're going to do something with it. So we select the source view that we want to use, and this is going to be a view that's defined on the VAST side for it. We're only going to see views that are related to this tenant. and it's going to ask for an event type. And this is going to be, did I create an element within it? Did I create a delete an element? Did I create a tag? Did I remove a tag? And these are going to be triggered off of Kafka topics, which we set for bucket notifications. And it tells us, here where's the broker that we're doing, what is the topic that we're looking for this, and then we get to define some other information. So what this is doing here is that as I upload an object into this particular bucket, into this pwags SC bucket, I want something to happen. I haven't defined what I want to have happen yet, but I want something to happen. And we also have here our functions. Now these functions are going to be your tied into Kubernetes are going to be based off of Docker images, and they're going to go through and do something. Now I'm not going to go through into the code and how these are created and how these are exactly done, but you have a Docker container or Kubernetes function that you want to go through and do that's already defined to do something. So in this case here, I do have one function here. I've got one here that's called LLM summarize. And what this is going to do is that this particular function here, it's going to basically go through and do a summarization of an object that gets uploaded. So I upload a text file, it's going to pipe that to an AI model, and that's going to summarize what that model was. And that's what that function is. Now, for the initial portion of this, we just needed to tell the vast cluster that, hey, this function is out there, tell it where it is, which one it should use, for this here. So it says, hey, we're using the SE Lab Docker registry, which we defined as part of the tenant. This is where we are getting this from. So we're looking for that particular image that's out there and which tag we're supposed to use. I'm using initial. It could be a specific version of those there. But once that's set up, then we can go through, we can start creating a pipeline based off of it. So pipelines are going to be pretty easy. I'm going to pipeline management. I can say create a new pipeline, and it's going to ask for some certain information here. It's going to say, hey, what's the pipeline name, a description. It'll ask for which cluster, should the Kubernetes cluster, which should it be using? What is the namespace that it's using within that? And then we can go through and set a few environmental settings along with those two, as well as if I need to have any S3 secrets that need to be defined here. So pretty straightforward, easy to go through and use. So let's look at an existing pipeline that I set some environment variables for here. And this one here is, I'm going to go through, this is going to be my summarization pipeline, and it's going to say, okay, we're using our Kubernetes cluster, and then I set a couple environment variables in here related to this. So first off, it's going to say, hey, what is the S3 endpoint that it's going to be using for this? So this is pointing again to a specific bucket or the specific S3 endpoint that is being used. I provide some S3 access keys in order to do this. Because this is going to use an AI language model, I have to provide it with the location of that AI language model and some other information as to how to get this. So I'm going to go through and send this off to a system we have there that's running this language model internal to our lab. So we set all those environment variables for this. These are all related to this. And then that is, once that pipeline is established or initially established, we can define what we want to do. So with this here, I have this configured, but if I want to go through and I want to, create a new pipeline here, I'm just going to run through an empty one here. Test one here, and we're going to say this here. When I go through and I do an initial creation of a pipeline, then I can come in here and I can define how these get put together. So in this case here, I've got my triggers that I would start. And the triggers, I can just go through and it's going to be as simple as drag and drop to set up these triggers. Now, I don't have a lot of triggers here for this, and this is going to be nonsensical with this demonstration here, but I could have different triggers to do different things. And then with my functions, I can bring my functions on here as well. And I can define, hey, when this trigger fires, I want you to run, I want you to go through and I want you to run, this function. If this other trigger happens to fire, I want you to go through and run, run this other function here or run the same function. So we can control this here. And it's very simple, very easy and intuitive to use. But going back to my example here for this, with my existing pipeline that I have here. This is a very simple pipeline. When I come in here, if I edit my go to my builder here, all that I'm doing is I'm taking this function, this trigger that says, an SE, an element was created. So an element gets created within the bucket, and I'm going to send that information about that object that got created to the summarize function, which will go through and bring that, make use of the Kubernetes function, which will send it to our language model and do something with that. So very simple, again, very straightforward. Now, what will happen here to kind of put all of this together is that once I have this pipeline defined on this and it's started and it's running, it's available, we want to actually make it go through and do something. So in this case here, I'm going to go through and I'm going to take a file here, and I've got just a text file that's defined here, which is has some information in it, a text summary for this, and I want to actually kick this off and have this summary. So the way that this operates, I need to go through and I need to put this into that particular bucket. So I'm going to go through, I'm just going to copy this file over into my bucket here. Oops, get this up into the bucket. So I'm going to copy this into that particular bucket, and we're going to watch what will happen here. So it gets uploaded into the bucket, and now for this here, depending on the system will see that, it'll set off the trigger, do the bucket notify, set the trigger, and then the pipeline will be initiated. But if I want to watch and see what's actually going on, I can take a look at the logs here. So I'm going to go through, I'm going to filter the logs here just in the past hour. So I'm not seeing anything else that I've been going on here. But what I'm going to see here is I'm going to see what happened. So I have here is that there was something that was triggered on this. So I see that, hey, there was a this was triggered. A file was uploaded to this. It was going out. It triggered this action to happen. And when I look at this object here, I'm going to see here what the results of that job were. Now I'm just logging this summary through into the log file. So I'm just putting a log file. So I'm not actually doing anything external to it, but it's doing that. So it took this file with this text in it and ran it through the language model that I defined as part of that function and gave me the summary of this in a very short, concise. So that basically is the way that this operates. Very simple to go through and do. I didn't have to do really any additional coding, and the functions were already defined for this, or you could write your own functions and put them up there. But I didn't have to know anything about how VAST operates in order to set up this particular pipeline, to go through and get this to have this functionality work. So very straightforward, very easy to do. Now, admittedly, this is a very simple example of things. It does make use of AI, but this could be done with any number of things. If I wanted to have this rather than sending this object off to AI to do some summarization, maybe I want to have some other operation that's done. Let's say I want to do some external processing of things that got put in. Let's say if I wanted to upload an object file to that, and I wanted to have some tags put into it based on some metadata that was contained with that. We could write functions and pipelines to go through and do this and have this all triggered internally into the VAST. So as Tomer pointed out, has been mentioned here, things like the Kubernetes cluster and the language and the language models there, these today reside all outside of the VAST clusters. They are maintained independently of this, coming with 5.5 and further on. We're looking to be able to bring these in so they can all be managed internally within the VAST as opposed to being managed as separate clusters. So, but very useful here. So that's the very quick demo of things. I'm going to stop sharing my screen here. And the other items here that typically will come up, or typically questions here with this, is, well, how do we go through and how do we perform an upgrade to get to the VAST 5.4 version. So when it comes to upgrades for VAST 5.4, these upgrades are done no different than any other upgrade that you would do on the VAST cluster. The VAST clusters are designed to be designed to upgrade transparently to end users. Non-disruptive upgrades is one of the hallmarks that we have with this. All of the upgrades here that you would do, all the functionality is already baked into the cluster, so there's no additional steps, no additional software that needs to be installed for this. Just to bring the upgrade package into VAST, and that's going to be pretty straightforward. So let's talk real briefly about how that gets accomplished for this. So first off, again, with any upgrade that we have for this, I would encourage you to go through and talk with your support, your customer success engineers, to make sure that you have everything ready to go for this. They can go through and look at the health of your cluster that you have. But the upgrades here are performed like any other upgrade that we would have. So with the upgrades here, we would go into our infrastructure page here. We go into our clusters page. And I'd come in here and I'd be able to select upgrade. Now, VAST upgrades, when we go through and we package our upgrade software here, it comes as a single blob, a single object. That object will contain things not only like just the VAST software, but also it will contain any underlying Linux OS updates, any kind of firmware updates that are required, will all be within this one single object here. So what you would do is you go through and you would tell the system to go through and import this. We provide it with the location of the bundle here for these, and once we would this could either be an S3 bucket location, or it could be a local file that was pulled down to your desktop or uploaded to the CNode, and then from there it's very simple to go through and do. You upload it, you tell the cluster as to what the location is, and you select what needs to be done. General system update is usually all that needs to be done. This will go through and update again just the VAST software, just the Docker containers that are run on the C nodes or the D nodes, or in the cases of the eBox, the C node and D node personalities on the eBoxes, and it will update. It will go through and update those in a rolling fashion, keeping the system available and accessible online while this is done. If there are cases where we need to update an underlying OS version, for the cluster, or for the C nodes or D nodes, or if there are firmware updates that need to be done on the system, we can select those as well. The main difference between doing these types of upgrades versus doing just the VAST container updates, for those, that they usually just take a little bit longer to go through, because there's more things that have to be done, some more tests that have to be done, but the process is generally the same. And then once that's done, or once you're ready to go, you just hit upgrade now, and it goes off and does it. Not much to go through and watch. It just iterates through the C nodes and keeps things online while that's done. And then once all the upgrades are done, all of the functionality that you would have in 5.4 is going to be immediately available to you from the version that you came from. No additional hoops have to be done post upgrade. Those are all handled automatically. So with that covers basically the updates for 5.4. A quick run through for the demo. Kristen, what other topics do we have? Otherwise, I think we can probably wrap up here.
Yeah, I'm going to jump in and a couple of key takeaways for the 5.4 functionality. So let me do a quick share here. Hopefully this was helpful for everybody. So with the 5.4, right, there's been a lot of changes and a lot of additions to this functionality, but there's a couple of key admin takeaways that we'd like to point out. We've increased security options. So this provides administrators additional security options and authentication options for their customers, for tenants, for however that might work. So again, expanding the functionality and increasing the capabilities and increasing security as well. Scale performance. So NFS delegations, global namespace, and snapshot functionality. So this is, again, expanding the scale capabilities of the already impressive scale that VAST is capable of. And then last but not least, the database functionality. So the enhancements in some of the existing database functionality, and then adding the vector store database functionality. So again, this is one of the things that a lot of customers have requested, and we also needed to add for a lot of the AI functionality. As you saw with some of those slides that we presented, how the vector database can be used, especially with AI and RAG functionality. So with that, we'll wrap up this session. Kristen, is there any other call to action that we have?
We do. So we have our annual user conference coming up in February. I'm just going to put some information about that in the chat. So we have a special track for VAST admins. So you're going to have the opportunity to take a certification exam. And we also have then information about our certification program. So I'm going to just, while Phil is reviewing the Q&A, because Phil, there's definitely some Q&A in there for you. Mm-hmm. That is something to make sure you're all aware of. We'd love to see you there. And with that, Phil, you've got a few questions to answer. You did the one on upgrades. I know we got one on NIMS. You take it away with the last bit of Q&A here.
So the last bit of Q&A. So the one question: are there special upgrade paths for the new KA from Trino and Spark on CNodes? Not directly. So when we're talking about running Trino and Spark on the CNodes, there, that basically is going to go through, and we will run that typically as a dedicated application on that CNode. So there's not really an upgrade that needs to be done. We're going to go through, we're going to take that CNode, and that CNode will run just the Trino. It's not necessarily going to run other types of functionalities there. So nothing really special needs to be done. It may require some re-architecting or changing the roles of some of the CNodes for that, but nothing else that needs to be really done with that. For NIMS, that's something that's still to be determined there. So that's something that's coming up with 5.5 again. These NIMS don't run directly within VAST today. They'll run. We can call those from that. Again, coming with 5.5, but something to be running internally. So I think that covers the questions there.
It looks like a DPU question as well.
Yeah, so the DPU, so for VAST to run VAST OS on the DPUs. So within we already do that to some extent. So within the D boxes themselves, those are running on DPUs effectively. They're running on Bluefield cards for those. If we're referring to other use cases, there is some possibility of those there. It hasn't been totally deprecated, but it depends kind of what the use case. So can't really go into more detail beyond that, unfortunately.
Awesome, thank you. All right, yes, and with that, I think we can wrap things up. Like is posted in the chat, we do put these recordings up on our YouTube playlist afterwards, so we'll send out an email as well with that. And we would love to see you on future webinars. We do these once a month and really appreciate you all joining in. So thanks so much for joining us today for this webinar.
Thanks for tuning in.
Thanks, everybody. Have a good day.